everyone, this is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at a very interesting topic, how to detect cycles in a directed graph. Let's start with what a directed graph is. Have a look at this picture. This is a graph. This is one of the non-linear data structures. Coming to what is the point of a data structure? Data structure is nothing but placing the data in a structure or an ordered form. And that order can be a linear order or a non-linear order. And graphs come under non-linear data structures, where one data item can be linked to any number of other data items, right? So have a look at this picture. Here you can see 4 nodes where they are related to each other. We can say that the node 0 is related to 1, node 1 is related to 2, and so on and so forth, right? So how to detect cycle in this? Then what do you mean by a cycle? If, say for example, let us talk about this example later. Let me take a very simple diagram or a graph and let me explain you what a cycle is. This is a graph G. Here there are 3 nodes, 0, 1 and 2. 0 is related to 1, whereas 1 is related to 2 and 2 is related to 0. So have a look. When you traverse from 0, you are going to reach 1. From 1 to 2. Again from 2 to 0 you can reach. That is, the source and destination are the same. Such a path is known as a cycle. Now the task is in a directed graph. Why I am calling this graph as a directed graph? Because here I can claim that there is an edge between 0 and 1, but I cannot say that there is an edge between 1 and 0. If I say this, then this will be an absurd, right? So in directed graphs, the edges depends upon the arrows, that is the source and the destination, right? So that's why we call this graph to be a directed graph. And just now you have learned what a cycle is. Then let's see how to detect whether a directed graph is having a cycle or not. So in a given directed graph, we have to check whether it is having a cycle, right? So your function, whatever the function I'm going to show now, it is going to return either the given graph is having a cycle or it is not having a cycle. That is a Boolean case, either true or false, right? So let's have a look at this picture and let's identify the scene. Okay, so in this graph, let's make a note of all the edges, right? So this is the graph G. The edges are 0 to 1, 1 to 2, 0 to 2, and 2 to 3 you have. From 3 we have an edge to itself. It is known as self loop. Then from 2 to 0 we have, right? So these are the edges which we have in the given graph G. Then how to identify whether this directed graph is having a cycle or not? With the help of depth first search, DFS. With the help of depth first search, we can easily identify whether the given graph is having a cycle or not. So for example, let's start with the node 0, right? So who are all the neighbors of 0? The neighbors of 0 are 1 and 2, right? The neighbors. If this is supposed to be an undirected graph, the neighbors would be 1 and 2, right? So have a look at the neighbors of 2. So the neighbors of 2 are 0, 1 and 3, right? So 3 neighbors. So do you have a path in such a way that a cycle is formed? Let's see. From 0 you can travel to 1. From 1 you can travel to 2. See, I have an edge from 0 to 1, 1 and 2, a label 1, and then from 2 where I can reach. From 2, I have an edge to 0. Yes, I have an edge to 0. Can you see that? The source and the destination are the same. This itself tells you that this given graph is having a cycle, right? So with the help of a Python program, I'm going to explain you how we can detect, right? How we can detect whether a directed graph is having a cycle or not. This is a very important and crucial question in case of placements or high-end program. Let's see an contrary example. Let me take one more graph. Have a look at this graph. Is this graph having any cycle or not? Right? So let's make a note of let G be the new graph, right? So the edges are 0, 1, 1, 2, 0, 2, 2 and 3. These are the 4 edges that I have in the graph, second graph, right? So let me start from any node. So let's start with the 0th node. I can reach who are all the neighbors 1 and 2, and from 0 I can reach 1. From 1 I can reach 2. From 2 I can reach 3. Max, at max, right? So I don't feel any that the source and destination are not equal. They are not one and the same. Okay, why always start with the 0? Let me start with some other node, say 1. From 1 I can travel to 2, or from 2 I can travel 3. Even here the source and destination are not same. Okay, let me start with 0 once again and let me check. Because there are 2 edges going out from 0. One is towards one node 1 and the other towards node 2. So let me take node 2 as the next one. Okay. So 2. From 2 I can travel to 3 at max because the only edge coming out of 2 is 3. So even here the source is not equal to destination. Fine. Fair enough. I'll start with 2. Am I having any next element, that is the destination of 2 is 3. The 2 and 3 are sharing an edge, but they are not the same, right? If I go with 3, there is no outgoing edge from 3. So definitely I have tried all the paths, all the possible paths, but nowhere I can see, not even in a single case, I can see that the source and destination are same. So with this note, I can say that the second graph do not have any cycles, right? So now using a Python code, let me explain you how to detect whether a graph is having a cycle, especially a directed graph is having a cycle or not. Okay, let's migrate to Python. Yes, guys. Here we are in the Python environment. I'm using the version 3.10, the latest one for your convenience. From python.org at any point of time. It is an open source. You can download and you can start programming with it. Okay, let me open a new file. Yeah, let's start programming, right? So I'd like to take the help of dictionaries for the same because graphs use dictionaries. Why graphs use dictionaries? A very simple question and a very simple answer for that. Let me take an example of a graph which is having, say, the edges. Let me take it as the 0th node is having the edges towards 1 and 2, right? And 1 is having an edge towards 3 and 2, right? Then how can we store this data? Very simple, by using dictionaries, where for the first one, I can say that D is equal to, where D is my dictionary. I'm not writing the complete code for the sake of example, where I can say that the node 0 is going to map to asset 1, 2, both the elements, right? 1 and 2 both. Or you can say a list, more simply a list, right? here if you give the value 0, taking the name of the dictionary, the values both 1 and 2 will be retrieved. That is the fun of dictionary. Take the name of the key, you will get the value in return, right? So the next one will be, 1 will be stored for, so 3 and 2, right? This is how easily I can work with graphs using dictionaries, right? So let me use the same. So for that purpose, I need to include collections, right? From for collections, I have to include dictionaries especially. Let me do that. From collections, I'm going to import default dict. Okay. From collections package, I'm going to import default dictionary for my purpose. Let's start working with this. Let me define a graph class, right? So I'm going to use object-oriented programming. Mostly for nonlinear data structures, either you work with trees or graphs. Nonlinear, we go for object-oriented concept of programming, that is classes. We talk about classes. You can view my previous videos, which I have already uploaded in YouTube, based on trees and graphs, working with them on all the 3D paths in all the 360 degrees perspective. Have a look. Okay, let me go with the constructor of it. Okay, which take self and vertices. So the constructor of graph class takes a parameter as the number of vertices, right? So let me initialize those variables. So self dot graph is equal to default dictionary of list. So I'm going to create whatever the list will pass, that I'm going to create a dictionary out of it. Okay, I'm going to convert that. Now, self dot v is equal to vertices. So whenever an object of class graph is created, this constructor gets invoked. Thereby, the two parts or the two member variables of this constructor gets working. Okay, right. Now let me go for adding the edges. First of all, to detect whether it is having a cycle or not, first of all I have to create a directed graph. For that, I have to bring connections between the nodes. Whatever the nodes I'm going to pass, I have to build a relation between them, right? So let me go for an add edge function. So def add edge, and to add edge, I need to have a source and a destination. That is, I need two vertices. Let me name them as U and V respectively. Okay, then fine. So have to group them. Very simple. Self dot for the graph U node, I'm going to append V as its destination. So have a look at this function, I guess. So for the graph, for the object, it is a dictionary, right? Using default dictionary, I have the constructor, I have initialized it, right? For the U key, the name of the destination will be appended as a value, right? So in this line, the above line, U is the key and V is the value for the dictionary graph. Okay, this is how I'm going to add edges to my graph. Right, then let me write a function for to check whether it is the graph is having. I have constructed a directed graph. Now I have to check whether it is having a cycle or not. Def is cycle util. Okay, then the parameters I'm going to pass to that are self, v, visited, and stack. As I told you, to detect whether a directed graph is having a cycle or not, I'll be using depth first search, and depth first search uses stacks. So to go in deep and understand how DFS works, that is depth first search works, please do visit my videos, guys. There I have explain using examples, that is graphs, as well as using Python code, how to construct DFS of a given graph, right? So, and for that in DFS, if you recollect, we need a parameter known as visited, right? In DFS, how we work. So from a starting node, check what are all the unvisited neighbors of that node and hop to the next unvisited node. So if a node is having more than one unvisited node, you can randomly choose one and jump. Take a hop. Okay? Fine. Let's start writing. Visited of b is equal to true. Initially, I'm going to make the first value of the given key as true because I have taken a hop, right? Then stack of b is true. So in the stack also, I am entering the value true with the corresponding destination, right? Destination node, right? So first, I have to check for the neighbor in self dot. I have to check for the neighbors, that are the unvisited neighbors, which I said just now, right? So self graph of B. So then now I have to start with all the unvisited neighbors of the other edge of the graph, right? Small typo error, which I would like to rectify so that I don't get runtime errors later. Okay? Then if visited of neighbor is false, that is, it is an unvisited neighbor. If it is an unvisited neighbor, then if I am going to write a recursive function for the same is cycle util. Is cycle util is the function which I'm writing right now, and I'm recursively using it also for neighbor visited, and the parameters which I have to pass. I'm supposed to pass 3 parameters to that. So I'm passing the neighbor, which is an unvisited one, and the visited, the list name, the visited, and the stack. I'll do this if it returns true. Then I'm going to return true. What if this is not the case, right? So elif. So what if there are no unvisited neighbors? That is, so in the if condition, I have checked whether the neighbors is false, right? That is, it is an unvisited neighbor. It is a hit. So I have done it. What if there is no unvisited neighbor? This is an important task. Then I have to pop the elements from the stack. Let me write the code for the same. Neighbor is equal to true. Return true. Right? So this is this contrary part. The first one within the for loop, the first one for unvisited, the other is for visited. Right? So at the end of, right? Once all the nodes are visited, I'm going to make the stack element, the width element as false, right? So I'm going to return it as false. So let me go for another function, which is going to judge whether the cycle whether the given directed graph is having a cycle or not, right? Let me write the same. So, and this function is also a part and parcel of my class. It is a member function, right? So visited is equal to This part goes for the basic initialization, where I have to create an array of elements which is of size of number of nodes in the graph, and make every node as false, that is every entry as false, that is at the initial state all the nodes are unvisited. Once we take the hops and we visit them, we are going to convert them into true. But basically in the first hand, I have to initialize them saying the whole list is false, that is no node is visited, right? The initialization part is what I am doing right now. So all the elements I am making it as false, right? So how many are there? The number of many, right? Then let's talk about the stack. Even the stack must be initialized. Even that is a list I'm going to use, right? Even in that, I have not appended any value right now, or I have not pushed any value right now. It is empty. So even for that, I have to make all the elements to be false. Self.v plus 1. Yes. Then for all the nodes in the range, that means within the list, right? For all the nodes, I'm going to check if the function which I have written just now, I'm going to use it. It will be called here, right? I have to check whether the graph which I have created and for which the visited list and the stack, recursive stack, is been initialized as a false, is holding a cycle or not, right? This loop is going to judge the same. That's why I told you while starting this function K, I'm going to write this function to judge whether the given cycle is directed graph is having a cycle or not, right? So if it is so, if this function returns true, then return true, simply saying that yes, it do have a cycle. If this condition fails, the for loop was running for all the nodes in the given graph and nowhere the condition is true, then you are going to return false, my dear. Okay, by the end of this if, I'm going to return false, right? So appending and everything is right. I hope I'm clear with this. Now I have to write the driver code to check whether my code is working or not. Let's do the same. Okay, let me write the driver code #DC, right? So let me create a graph. Yes, I'm going for a static one. I'm not going for a dynamic one. I straight away give the number of nodes and the relations between them. And using the add edge function, member function of the class, I'm going to construct a directed graph straight away, just using simply just 4 nodes as a sample. If you want, you can use this code and change the number of nodes and the relations between them, and you can check whether it is working or not. Okay, let's do it. I'm creating I have taken an object. I have created an instance of the class, an object, right? And we have seen that the constructor takes the number of nodes. The number of nodes I have taken are 4. Let me add edges to the same. So g dot add edge is the function which I have written. Yes, the spell is right. So let me build these relations. So g dot add graph of say the next edge be 0 to the relation. Okay, sorry, the add edge is the function I have written. Right. G dot add edge. Next edge be, let the relation be 1, 2. Guys, using a pen and paper, you can draw these edges and see This is a directed one. As I said, we are working for a directed graph. So here I have claimed that there is an edge between 0 and 1. Then it implies that there is no edge between 1 and 0 unless I declare it. Okay, right. G dot add edge of 2 0. Add edge of 2 comma 3. G dot add edge. Guys, I hope you know. I have created 6 edges over here. I hope you know the point of objects, basic classes, what a class is, and how object-oriented programming works. Guys, this is a prerequisite for data structures to understand specifically non-linear data structures. Fine? Okay. I have first of all, I have invoked the constructor saying that my graph will have 4 nodes. The names which I have chosen are 0, 1, 2, and 3. And I have used the add edge member function of the class, and I have established the relation between them. So let me call the main function for the same. If g dot is cycle, as I said, guys, I'm going to use this function is cycle to check whether my directed graph is having a cycle or not, right? So just print true. Else, as I said, I'll be writing a Boolean result for the same. Okay, so if the is cycle function is going to return true, then the result will be true, saying that yes, the given graph is having the cycle. If returns false, then it is going to say that it is not having any cycle. Okay, let me go through the whole program once again, and let me tag a important user-friendly statement. Guys, please don't forget to write implementation of a Python code for detecting a cycle in a directed graph, right? So let me save this with the name cycle. So it is directed graph. So DG is the tagline I have given. Okay. So have a look at all the code. We check whether it is having any typo errors or not. As far as my view goes, I don't think it is having any. Right. Fine with it. Okay. I have taken this as capital. Let me make it as small. Okay. Right. Okay. Let me execute this one. Yes. The result is true. So the given graph is a directed graph which is having a cycle. I hope you understood this one, and thank you for the same. Please do visit my site. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.